In the last few classes, we have completed the all the types of partial differential equations, first order non-linear partial differential equation, as well as higher order partial differential equation. The higher order PDE, we have completed all the 5 types here based on the right hand side function. And the first type is when RHS function is exponential, single exponential function, e power ax plus by. How can you proceed? And similarly, second type is right hand side function is cosine function or sine function. Right? Cosine function or sine function. How can you proceed? Okay? How can you proceed? That we have completed. And then third type is RHS, right hand side function is algebraic polynomial in x and y. Algebraic polynomial in the x and y, like x power m, y power n relationship, x power n, y power m relation. How can you proceed that here? And the fourth type is exponential product of two functions, where first one function is exponential. Other function is either cosine or sine function or algebraic polynomial. Cosine or sine function or algebraic polynomial. And then how can you proceed here? Product of two functions in which you can get cosine or sine function in the product, and as well as one more function is exponential function. One more function is exponential. We have to give preference to exponential first and replace d by a, d by d plus a, d dash by d dash plus b. In that manner, we can proceed. And fifth type is other than these 4 types. Suppose you have a right hand side function, that function is other than these 4 types here, then how can you proceed here? That will be the fifth type, in which you can operate integrations directly in the particular integral. Integration directly in the particular integral. In that manner, we can proceed. I can proceed. About these are the 5 types we have completed here. And further, we have 2 application problems here that we will discuss tomorrow. Tomorrow we will discuss applications problem tomorrow here. And remaining topics we covered. The syllabus, we have 2 problems. Particularly, we have 2 problems here. We will discuss tomorrow. And then remaining topics are covered in that first part here, homogeneously up to homogeneous linear PDF, constant coefficients. Right. These are the things you are going to consider. And then today is Wednesday, and Saturday you write a test. You write a CA test under this topic here, the whole first unit here, under this topic. I will give some objective type questions only. I will provide, you can choose the answers here. But problem will be a lengthy problems here, big questions. But you take it as a objective type questions here. Problem will be given, choices will be given. You have to solve and then choose the best answers. That will be the idea we have to follow here. That is the idea. We have to write a test on Saturday. So the Saturday itself we have complete all the topics of first unit here. And then we'll start Monday second unit. And before that, the higher order PD we have completed previously. We have completed a higher order PD. Before you take today, you take for your practice session, you take some 5 problems here. The CA question, 5 questions only will be given. 5 questions will be given. Each carries 2 marks here, and the 5 into 2, 10 marks here. But it's not like a 2 mark question. It will be a big question type. You have to solve and choose the correct answer. Duration 1.5 hours, 1 hour or 1.5 hours you can take. Depends upon the lengthy of the question. I will allot 1 hour or 1.5 hours.
So class time only.
Class time only. Within the class hour duration, you can proceed. No need to upload or anything here. Just you have to choice, or to made a choice of the answers. Work out and made a choice. Okay. Today you take some 5 problems for your exercise for your practice session of higher order PD, and give your answers one by one. Give your answers. Okay. Okay. Write down the first problem here. First problem that is mentioned here. Number one. Number one. Solve the following PDs. Totally you put that solve the following PDs. All of you just note down and give your answers one by one. Solve the following PDs. First one, d square plus dd dash plus d dash minus 1 of z. D square plus dd dash plus d dash minus 1 of z equal to sine h of 3x minus 2y. Sine h of 3x minus 2y. Sine h of 3x minus 2y. You see that here, even though it is not in the type here, but sin h hyperbolic function, sin hx can be written as exponential form. E power x minus x by 2. Sin hx can be written as the exponential form. E power x minus x by 2. For this sin h of 3x minus 2y can be written as 1 by 2 of e power 3x minus 2y minus e power minus of 3x minus 2y. E power minus of 3x minus 2y. That is the first problem. Therefore, we can proceed by first type, particular integral. Second problem. But you see that in the first problem, yeah, 1 is appears here. Therefore, don't touch, don't alter any of the one here, one value, and then we can proceed as it is. Replace d by 3, d dash by this minus 2. Similarly, for this also you can replace. But you keep 1 as it is and find particular number. Second problem, d square minus dd dash minus 2d dash square plus 2d plus 2d dash of z, 2d dash of z equal to cos 2x cos y, equal to cos 2x into cos y. So it is like a product of cosine function here, cos a cos b. Therefore, you can write as 1 by 2 of cos a plus b plus cos a minus b. That manner can proceed. Cos a plus b cos a minus b. And then you replace d square d dash square minus a square minus ab minus b square. But you can, it will remain as it is here. You have to multiply by conjugate. Third problem, this one, it is type 2. This is type 3. D square minus dd dash plus d, only d here, plus d of z, d of z equal to x square plus y square, x square plus y square. X square plus y square. D square minus dd dash plus d of z equal to x square plus y square. This third type. In this particular integral, if you take d as a common element here, you can get 1 d minus d dash plus 1 you can get here. The particular integral, And the third problem, if you can proceed by algebraic polynomial here. So in the particular integral for third column, if you take d square minus dd dash plus d and dd dash plus d of z x square plus y square, but here d is present, therefore we can take d as a common element, 1 minus 1 minus, or you can take, suppose if you take d as a common element, d minus d dash plus 1, plus 1. In that one I can write x square plus y square. Or if you take 1 by d, then you can write this 1 minus of d dash minus d, d dash minus d whole power minus 1 x square plus y square. That is a simple way. If you take d, because a constant appears here, for that constant you can keep it like this. 1 minus of 1 by d, you can leave as this here, d minus d dash and plus 1. So I can write 1 minus x whole power minus 1. The expansion depends on square terms, d square and d dash square. Up to that, wherever you find d square and d dash square, wherever you find d square and d dash square, up to you have to expand. You have to expand. That is third one. And fourth problem is a product of function. Fourth problem is a product of function. D square minus 3d dash plus 2d dash square of z. D square minus 3d dash plus 2d dash square of z equal to 2 plus 4x into e power x plus 2y. 2 plus 4x into e power x plus 2y. Product of exponential into algebraic polynomial. Exponential into algebraic polynomial. For type 4, you can proceed. And we just note down this problem. And fifth problem, this is type 5. Product of algebraic and cosine function, therefore type 5 you can proceed. D square plus dd dash minus 6d dash square of z equal to y cos x. D square plus dd dash minus 6d dash square of z equal to y cos x. Y cos x. Yes, all of you try these 5 problems here. All of you try these 5 problems here and then give your answers one by one. Don't sit in a lazy manner. Everyone, please take a paper and a pen and try. I will ask the answers randomly from you. So please try and solve all these 5 problems one by one. If you attain any doubt, immediately ask, I will rectify. Please try it, and if you have doubt, please ask immediately, I will try.